What's up everyone, welcome back. We're taking a look at another LeetCode SQL 50 interview question. LeetCode's curated list of top 50 SQL questions to get started with. This was marked as easy. It's called average selling price, numbered 1251. It's part of the basic aggregate functions section, so that's what's to expect here. Let's just get into it and solve this one. For this one, we have two tables, one called prices and one called units sold. Our task is to write a solution to find the average selling price for each product. Average price should be rounded to 2 decimal places. If a product does not have any sold units, its average selling price is assumed to be 0. Return the result table in any order. The result format is in the following example. So let's take a look at the data format and example data we have. So in terms of data format, we have a product ID, which is just an integer. We have a start date and end date, and then a value for price. So this table pretty much contains a time period and a price for a given product. So a product might change in price. So for a given week, it's 10 USD, and then it jumps to 20 USD. And we have that time period encoded in here, which seems to be important for the question. In the table units sold, we have the product ID as well. So we can probably use that to join. We have a purchase date, which tells us when someone made that purchase, and then the amount of units purchased at that given date. Now, if a purchase was made on a specific date, we can assume that there is sort of a price for that date range in the other table. So that's what we're working with probably. In terms of the example input data, we have products start and end date. Seems like those are all in 2019. And then purchase data also in 2019. We have two different products, which would be in the output for this example. Product ID 1 and 2. Average prices of $6.96 and $16.96. So both products switched prices after a while. Which is encoded in here. And people have purchased different units. So good example data. Let's get back to the question statement once again to kind of make sure we capture everything. I've talked about pattern recognition a bit on the channel. So if you're looking at a question, look out for specific keywords to sort of signalize what you have to do in the question or what kind of question it even is. So for this one, it tells us to find the average selling price. So we're going to have to use an aggregate function, the average function, to get an average. It's quite easy. For each product. If it says for each or just each, then that means we have to group by a specific column, in this case product. Whenever you see each in a question statement, you can probably assume to use a group by, most likely. And column should be called average price. It should be rounded to 2 decimal places. We're going to have to use the round function. And if a product does not have any sold units, its average selling price is assumed to be 0. Now that is really interesting information. We have two tables and we should return 0 in case there are no purchases. So that should ring the alarm bells in our head to use a left join because we assume there is a product. There are no sales. We still want to list the product. So we're going to left join the sales table. If there's nothing, if there are null values, when we did the matching, then we want to display 0. So that is another pattern recognition keyword. If it does not have something, then do something. So that sort of signalizes using a left join. So watch out for that. Should return the result table in any order, and result format would just be product ID and average price. I think we've done a good job of sort of going over that example. We have a good calculation down here of actually explaining the final values, so we might get back to that. But for now, let's just start coding this up. I think I'll leave this sort of section on the side with the product statement and example data. So since we want to output product ID and the average selling price, I'm going to leave a placeholder here for average price. So ... as average price. And yeah, focus on the joins first maybe. So we're selecting from prices, which should have every product, and then units sold might not have any product because these are the actual sales. If there are no sales for a given product, then we still want to list it. So prices is our sort of base table, left side of the left join, which will be included in the output no matter what. It's sort of a registry for all products as well. But yeah, even though the main purpose is displaying the prices, it has our products assumably. So from prices, we want to left join units sold, and the join condition should be product ID, of course. And then, wait, let's spell this out. Prices.product ID should equal units sold dot product ID. And yeah, that way we can establish that join based on the product ID. But what's really important here is the date range of when a product had a specific price. So if we wanted to match that purchase of 100 products with product ID 1 being purchased on this specific date, then yeah, we would still have two options to join it to here in the prices table, or the other way around. But yeah, what really gives it away is the purchase date. So purchase date 25th of February would be in this price range here, and the product was actually just 5, whatever currency they have, instead of 20. So we need to add that to our join condition. We're just gonna write and prices, well, the other way around works better here. We want to make sure that units sold dot purchase date, so the purchase date of the actual product, is between the start and end date in the prices table, so that price range. Yeah, I'm gonna spell out that this is coming from the prices table as well, even though it only appears once across these tables, and separate that as well. Yeah, I hope that makes sense. So you're joining based on the same product ID, obviously, and then you want to make sure your purchase was in that actual date range. For that to work properly, the date ranges can't really overlap, which they shouldn't if, yeah, a product can only have one price at a given point. So that should be reflected in the data. That is sort of an assumption we make, but it's a fair assumption to make if you ask me. Yeah, so that way we sort of look up a price for a given product at any given moment using that start and end date. And that way we can actually calculate the price at that point, and then we just need to take the average and round it. So going back to the examples down here, explanation, average selling price is actually the total price of a product divided by the number of products sold. So let's fill out that placeholder here, replace the placeholder here by actually calculating the amount of units, like in this case 100 times the price, 5, would be the actual total price of that order. And yeah, that is only possible after we did that left join and made sure we know the price at that point. Yeah. So yeah, with the code we currently have, we would get the total price for each purchase. But in order to get the average selling price, we would have to add to that calculation. It would be enticing here to sort of just take the average of all of those, but then it would be per unit, and yeah, it's not really what we're being asked for. Average selling price for each product, individual product. So in order to get that, we will sum this up and then divide it by the sum of units. So we have that overview of pretty much what we have here. So we calculate the total purchase price of a order and then do that for every order of product. And then we also sum up the number of products sold. So in this case, it's 100 plus 15. And they just specified 115 here straight, but it's actually also an addition of those two orders. Yeah. So that might have made it easier. So we'll do that. And then we're just going to wrap this with a round function because we were asked to round to 2 decimal places. In order to do that, we're going to specify what we want to round within the parentheses, and then comma and the amount of decimal points, decimal places we want to have. We can return in any order, so we should be fine there. But since we want to do this for each product ID, per product ID, we need to remember to group by the first column being product ID. So group by 1 or group by product ID. Speaking of product ID, this column appears in both tables. So in order to not get an error, we should specify which one of the 2 versions we refer to. Yeah, in this case, it should be prices because there's not necessarily an order for every product. So yeah, it's best to select from prices. The left table should have every product. All right, so let's run this, see what it gives us, and see whether it is accepted. So this one is accepted, passes all test cases. Let's submit it and probably end here. Yeah, did the expected output, all the right formatting, all the right naming. I think we ran into that null value if we calculate that sum. So in order to circumvent that, we can just wrap this entire thing with a call-less function or an if null function. And similarly to the round function, we can specify after the comma what should happen with that expression. If it is null, then we'll just replace that with 0. And that's a good catch and something only reflected in another test case. So let's add it here and we should be done. And yeah, that's accepted. That's been it for that question. If you want to give this one a try, I'm going to have a link down below, but I also have a place on every LeetCode question in SQL 50. I'm going through all of them. So if you haven't checked out the playlist yet, I highly recommend you doing so. And you can work through all of the different problems with me. And at the end, get that badge of solving all of SQL 50. And I think then you're greatly set up for a career in data science or data analytics. So yeah, keep studying with me and I'll see you in another video. Bye bye.